On the FE exam, you are going to need to be able to determine integrals. And when you hear the word integral, you should be immediately thinking of what is the area under f of x with respect to x from the limits a to b. And so in this video, I'm going to be working through the integral from 0 to pi of some constant a times the sine of x dx. And when you're working with trig functions, I really like to think of the unit circle, in which we have a circle of radius 1 and it's centered at 0. And basically, as you rotate around this unit circle, you ask yourself, what is your x value and what is your y value? And so cosine of theta refers to your x value, and sine of theta refers to your y value when you're thinking of this unit circle. And this helps a lot because basically, if I were to ask you what is sine of pi halves, well, theta at pi halves, we know that sine of theta is equal to y. Y on this unit circle is equal to 1. So we know that sine of pi halves must be equal to 1. And cosine of pi halves is your x value, and that must be equal to 0. And so this does help out, especially when you're trying to plot these functions, just to visualize what you're doing. And so in this case, because our function is a times the sine of x, if we were to plot this, what we would have is something that looks like this, where we'd have our y-axis bounded between plus and minus a. And essentially what we're being asked to do is evaluate the area under the curve from 0 to pi. So we're interested in determining what this area is for sine of x dx. And so when you hear integral, another term you should think of is antiderivative. And so when you take the derivative of something, what comes out? And in this case, remembering that when we take the derivative of cosine of x with respect to x, this is equivalent to minus sine of x. And to do a little bit more review on what derivatives and differentiation really are, it's nothing more than the slope of these lines. And so another reason I've plotted these two functions on the bottom right here is to help us visualize why intuitively we're seeing what we're seeing. We'll also recall that the derivative of sine of x with respect to x is equivalent to cosine of x. And so by looking at these plots, things will begin to make a little bit more sense. So what we see here in sine of x is if we look at our very first point at theta equals 0, so this x-axis I can think of as just being theta, what we see is that this line has a slope right here of 1. And once it reaches pi halves, the slope becomes 0. And once we reach pi, the slope is now minus 1. And so intuitively, we see how the derivative of sine of x, which is a fancy way of saying the slope of the line of sine of x, is equal to cosine of x, because it's very easy to see that when we're at theta equals 0, cosine of x is equal to 1, which is the derivative of sine of x. Now things do get a little bit trickier with taking the derivative of cosine of x, because with cosine of x, while we are at 0, we see that the slope of this line is 0. But once we get to pi halves, we now have a slope of minus 1. But our sine function has a value of plus 1, so it needs to have this negative sign here for it to make sense. So it is good to understand a little bit of the intuition behind these functions. Anyway, moving on and actually taking this integral, what we would find is that the integral, because a is a constant, we can pull it out of our integral, but the integral of sine of x is really equal to minus cosine of x. So this term here is going to be equal to a, and I'm going to pull out the minus 1, the minus 1 times the cosine of x. And now we're going to have quantity cosine of x evaluated from 0 to pi. And so what this tells us is that we have minus a times the quantity of cosine evaluated at pi. And if we now turn and look back to our unit circle here, what we see is that cosine of pi is a fancy way of saying what is x equal to at theta equals pi. And we see that x is very simply equal to -1. So we're going to have -1 minus, and then cosine at 0. And so at 0, x on our unit normal circle is equal to +1. So we're going to have -1 minus 1. And this is going to be equal to -2, and then times this a. So this whole term is going to be equal to +2 times a. And so this is how we can integrate and get a little bit more familiarity with our trig functions, which will help us out on the FE exam. And so thanks for watching, and I hope you guys find this useful.